What is osmosis? And what is tonicity? Osmosis is when the solute particles or H2O particles move from a high concentration to a low concentration of solute particles. And tonicity is when we have two different solutions at different concentrations separated by a semi-permeable membrane. And the goal of osmosis is always going to be to go from this high concentration to low concentration until equilibrium has been achieved. So what is the relationship between osmosis and tonicity? So here we have two solutions. On the left is a solution that has a higher concentration of solute particles. And on the left, we have a solution with a lower concentration of solute particles. So both solutions are going to contain equal amounts of water. However, on the left, we're going to have a lower concentration of solvent molecules or water molecules, and on the right, we're going to have a higher concentration of solvent molecules or water molecules. As you can see, the solute particles are too big to pass through the semipermeable membrane. Therefore, the process we're going to use is osmosis, where the water molecules are going to move from a high concentration to a low concentration. And so with tonicity, the solution with the higher solute concentration and the lower solvent concentration is going to be the hypertonic solution. And then the solution with the lower solute concentration and the higher water concentration or solvent concentration is going to be the hypotonic solution. So to answer our question, what is the relationship between tonicity and osmosis? Well, with osmosis, the water molecules are always going to move from a hypotonic solution to a hypertonic solution, which creates an isotonic solution. And an isotonic solution is a solution that is at equilibrium. So both sides or both solutions have equal concentration. So in another example I like to use, we have a beaker separated by a semipermeable membrane, and on the solution on the left we have a high concentration of solute particles, and on the right we have a low concentration of solute particles and an equal parts of water. And so on the left side we have a hypertonic solution, and on the right side we have a hypotonic solution. And like I said before, the water molecules are always going to move from a hypotonic solution to a hypertonic solution. And so the ratio of solute molecules to water molecules in the hypertonic solution is going to be greater than this ratio of solute particles to water molecules in the hypotonic solution. So since the water molecules are going to move from a hypotonic solution to a hypertonic solution, the water molecules in the hypertonic solution is going to increase, while the water molecules in the hypotonic solution is going to decrease. Thus, the solutions are now at equilibrium or equal concentrations, which is also called an isotonic solution.